Heyo, it's Mr. Otwell, the Math Master, helping you master math, and today we'll be solving linear equations. Those are the ones with nothing crazy going on. There's no exponents or square roots or anything like that. We just need to get x by itself, but sometimes we have crazy fractions or a bunch of distribution happening. I'm going to share with you the tips that I kind of keep in mind as I go about them, and if you follow along to the end of the video, give this video a thumbs up, and don't forget to subscribe so that you can continue to support me and this channel so that we can help more people master math. Let's do this. So solving linear equations, we're going to start more simple, straightforward, what we're used to, and then build into some super exciting stuff with fractions. I know they're your favorite. So when we're solving a linear equation, in this case, we're solving for x. We're really just trying to get x by itself. We want to know what value, when we substitute it in right there, will give us an equation that is true, meaning what x value will make this side equal to 30, because we already know the right side is equal to 30. What x will make this whole side equal to 30 once we choose the right value? So to solve for x, if we end up with some sort of expression on the left side that has parentheses with a number on the outside, that is our key. Bam, we need to distribute. It is the distributive property. I've written it right up here. This is when we have a number outside the parentheses. One thing to keep in mind is there's a little multiplication symbol right here. We just don't write it, okay? We're lazy in math. We're just trying to make some shortcuts. But what this is saying is -4 times x plus 3, that whole thing. So when we have more than one term inside the parentheses, we actually have to do this multiplication operation to every single term inside the parentheses. Additional note here, one thing that I see students struggle with or make little mistakes, I even do it sometimes myself, is we get lost in the negatives, okay? So what I think is helpful is if before you even think about the number that you're gonna get, just think to yourself, okay, I have a negative times a positive, that gives me a negative. So you already have the symbol that you need for this term. If you have a -4 times x, you're just gonna get -4x. When we multiply a constant times a variable, we just write them together with -4 as the coefficient with x. Then we distribute, we multiply the -4 times 3. Negative times a positive gives us a negative. So let's write that. Then think, what's 4 times 3? We have 12, right? And we didn't do anything on the right side here, so we just bring everything down. Right now we only have 30, so it's good. Since we're trying to get x by itself, if it's in that parentheses, we gotta get it out. There's no way for us to use some sort of operation to isolate x without getting it out of the parentheses. So that's why we distributed first, okay? When we have the x inside the parentheses, 9 times out of 10, we're gonna go ahead and distribute. So now that our x is outside the parentheses, we can actually just try to get our x by itself. So we have -4 times x. So there's multiplication happening on x, but we also have subtraction. We have -12. So what we're trying to do now is undo every single operation that is happening onto x, okay? So we need to undo this operation of multiplication. We need to undo this operation of subtraction. So what do? Well, in Algebra 2, we use our handy dandy inverses. That is a main focus of this course when it comes to solving equations, using operations and their inverses in order to solve equations. So when we have multiplication and subtraction going on, generally what we're going to do is we're going to take care of the subtraction first. You've probably heard of Pemdas. This is the simple steps you would go for the order of operations. Sometimes it's a little more interesting than this, but it's a good reference point to just go. This is generally the order you would go in if you're operating and just evaluating an expression or finding an answer. But actually when we're solving equations, sometimes we just can think about it going backwards. We're going to deal with addition and subtraction first, then multiplication, division, then exponents. Then if there's any lingering parentheses, we could take care of that. So in this case, we have -12. Well, what we're doing here in Algebra 2 is we're using inverses to isolate the variable, meaning get the variable by itself. So we think to ourselves, what is the inverse operation? What is the opposite of subtracting 12? Well, what's the opposite of subtraction? Addition. So we're going to use that inverse operation of addition to get rid of that 12. So the opposite, the inverse of subtracting 12 would be to add 12. But look at what I've done. I have just added 12 to the left side of this equation. Now, that was the key. Did you hear it? I said equation. You see this guy right here? Right here. Bam. That's a very important symbol. It actually has meaning. What it's saying is everything on the left side of the equation is the same as what's on the right side of the equation. So it's saying everything on the left side of the equation is equal. It's the exact same thing as everything on the right side. So if you choose to operate and add 12 to this left side, in order to keep it equal, you have to add 12 to the other side. You have to. What you do to one side, you have to do to the other, okay? Because it's equal. Because it's equal. It is very important that you really understand what is going on when you solve an equation. So just for this first problem, I'm going to add a little bit of steps in here. I generally wouldn't write this when I'm showing my work, but I need you to understand something, okay? Now that we have still an equal equation, right? The left side is still the same as what's on the right. We need to go ahead and operate and add 12 to both sides. Now, I want you to notice I put this plus 12 right underneath this minus 12 for a reason, because one of the things that kind of gets messy, and it's really where I see people struggle the most when we get down to stuff like this, is really just not being as organized when you're choosing what to do with your equations. So you cannot combine negative 4x with 12. So it doesn't make sense to put it right there. But you can combine the negative 12 with the 12. And really, this is what we're trying to get rid of anyways. So let's just put our work right underneath what we're trying to operate on. And in the same way, like, let's just go ahead and put the plus 12 right below the 30 so that we can just do all of our operations organized in a vertical manner. So we didn't do anything to this negative 4x. So if we didn't do anything, it's still there. We can't forget it. So we just bring down this negative 4x. And I like to bring it down just right below it. Now, here's this extra little step that I'm going to put in here. Negative 12 plus 12, when you add those together, you get 0. So you're really adding 0 right here. This doesn't like magically cancel it and it's gone forever and you don't have to worry about it. You're getting a number. Negative 12 plus 12 is 0. I've written that down right here. We call this the additive inverse. It's when you take some number and you add the negative of that same number, you get 0, okay? So if we continue along with showing our work, this equal sign is right here. And notice I'm keeping my equal sign generally kind of in the same column. This really helps with organization. Then 30 plus 12 is going to give us 42. Now we have negative 4x plus 0. Check it. Anything plus 0 just gives us whatever it is we started with. So negative 4x plus 0 is just negative 4x. We didn't add anything to it. This is what we call the additive identity. If you add anything to 0, you just get what you started with. That's called the additive identity. And once again, we didn't mess with 42. So we just bring that down. Now we're almost there. We're trying to get x by itself, but we still have negative 4 times x. So what is the opposite? What's the inverse of multiplication? Well, division. So in the same way, we thought, what's the opposite of subtraction? Addition. And then we just added whatever we were subtracting. We're going to think, well, the opposite of multiplying, because remember, right here, there's a little multiplication symbol. We just don't write it. If you ever have a number right beside a variable, that's saying multiplication. If we need to undo this negative 4 times x, we will do the inverse operation. We'll do the opposite. The opposite of multiplying by negative 4 is dividing by negative 4. So, as we said before, what we do to one side of the equation, we must do to the other side. So, we're going to go ahead and divide by negative 4 on the right as well. Once again, I'm going to show a little extra step here that I usually wouldn't write, and I'm not going to as we go, but it's really important that you see what's going on. right here, you have -4 divided by -4. This doesn't just cancel and disappear forever into the math ether, right? I mean, generally speaking, when I show my work going forward, I will do this, but it's really important that you understand -4 divided by -4 gives you a number. So let's write it. What's -4 divided by itself? Well, it's 1. So really what you're getting here is 1 times, well, you still have that x. So x, okay? Here on the right side, we have 42 divided by -4. Just for now, we've got a positive divided by a negative. So that gives us a negative number. And we'll just leave this as a fraction for now as is. And we'll reduce here in a second. What we did here when we divided by -4, we actually did what we call the multiplicative inverse. When you multiply something by the multiplicative inverse, you get 1. Now you might be saying, Mr. Otwell, you're multiplying here, but you're dividing here. You don't know what you're talking about. Oh, but check it out. Look, do you see how x times 1 over x? This is multiplying. If you look at our property here, one thing you need to understand is that division is multiplication. You're actually just multiplying fractions. And we're going to use that idea here pretty soon. But keep that in mind, okay? When we're dividing here, this still is the multiplicative inverse. The opposite of multiplication is actually really multiplying by 1 over whatever we're multiplying by. We just call that operation division. So now we have 1 times x. Well, 1 times anything is just whatever we started with. If you look over here, this is what we call the multiplicative identity. If we have anything and we multiply by 1, we get what we just started with. So this is the multiplicative identity. And that's what we're doing here. 1 times anything is just itself. So we're down to our solution. When we have a fraction, we're just going to simplify it and leave it. We're not going to write it as a mixed number. We're not going to put it as a decimal. 9 times out of 10, we just want to leave it as a fraction because that's the most precise way we can represent that value. So if we have -42 over 4, we need to reduce this. To reduce a fraction, you just think, what can I divide the top and the bottom by? So in this case, since both numbers are even, you can divide by 2. So let's do that. 42 divided by 2 gives us 21, and 4 divided by 2 gives us 2. So we have -21 over 2. And when we're solving an equation, we can actually just check it. Does this really make the equation true? Does it make the left side equal to 30? Well, pulling up Desmos, we can see here's the left side of our equation, -4 times x plus 3, -4 times x plus 3. And I went ahead and already substituted in -21 over 2. And that's what we got. Hey, look at that. It's equal to 30. So we know that when our x value is -21 over 2, it's equal to 30, which makes our equation true. So we know, bam, for show, that is our solution. So for our next one here, we have everybody's favorite, a fraction. Now I know what you're thinking. This is going to be terrible, but it's okay. Fractions are your friends, okay? But let's be real. Usually they do cause us some issues. It can make the calculations a little more difficult. And really, we just want to be as precise as possible and cut out as many errors as possible. So how about we just get rid of them? So what can we do to make our life a little easier? Well, we can multiply. Remember how before I mentioned multiplying by a fraction is the same as division. Division is the same as multiplying by a fraction. Well, we can use that to our advantage. If we can just multiply this fraction by some number that just makes it be reduced, there we go. We're in the clear. So the easiest way to do this every time is just whatever that denominator is, multiply by it. Now, you cannot just multiply this one term by 8. Our denominator is 8, so that's what we want to multiply by. We have to multiply the whole side. In the same way over here, when we added 12 to one side, we had to do it to the other side, same thing. We want to multiply this one term by 8, but in order to actually do that, we have to multiply the left side by 8, and we have to multiply the right side by 8. This is the only way we're going to be able to simplify that fraction. So once again, we have a number outside of parentheses we can distribute. So we have to multiply the 8 by all the terms. 8 times 1/8, that's the same as 8 over 1 if you wanted to write it that way. So you have 8 times 1 over 8. That gives you 8 over 8. And check that out. It just reduces to a 1. So when we distribute 8 here, we get just x. Really, it's 1x, but we're just going to skip that part from now on. 8 times 3 gives us 24. And then we cannot forget to actually do this multiplication. 6 times 8 is 48. So now we're just isolating x. We're going to use inverse operations. The inverse of adding 24 is subtracting 24. And what we do to one side, we got to do to the other because it's equal, right? So then we've lined it all up with our like terms. We didn't do anything with x, so we bring that down. 24 minus 24 is 0. In this case, we'll go ahead and skip that. And it's equal to 48 minus 24, which gives us 24. And as always, we can just check our solution, see if when we plug 24 into the original equation, does it really make everything equal? Does it make a true statement? And as we can see right here, on the left side, we had 1/8 x plus 3. When we substitute 24 in for x, that was our solution, we do get a 6. And that was what our original equation gave us. That wasn't too bad, right? It started with scary fractions, but then we can just multiply by a certain number to get rid of all the fractions. Most of the time, your go-to is just whatever that denominator is, multiply by it. If you just have one fraction in the whole equation, multiply by the denominator, make sure you multiply every single term, and then bam, your life becomes easier. No more fractions. It's so nice. Now for problems like this, when you just have a bunch of everything going on and you've got parentheses and multiple terms everywhere, just distribute first. Just distribute first. It usually is just going to make everything a lot easier to look at, a little less intimidating. So remember, this is 2 times negative x plus 3. So we're going to multiply the 2 times every single term inside. So 2 times the negative x, remember, positive times a negative gives us a negative. And then 2 times x is just 2x. 2 positive 2 times positive 3, that gives us a positive 6 equals. Now, hey, check it. Let's just go ahead and distribute this side as well. Let's do the negative 3 times x, negative 3 times negative 7. So we have a negative times a positive gives us negative, and then 3 times x is 3x. Then a negative times a negative gives us a positive. So, we're focusing on that sign there in the front first, then we'll think about the numbers, then 3 times 7 gives us 21. Now we have a situation where we've got a variable of x on one side and on the other. So since we're trying to isolate x, we're trying to get it by itself, we need to do something so that our variables come together and just become one term rather than two. We don't want more than one. Let's just get all of our x's together. We really kind of just wish that negative 2x wasn't even there, because then we would just have one term with x, or vice versa, right? If we could just get rid of the negative 3x, then there'd only be one x term. Once again, we can't just cancel it out. So what do? You guessed it again, inverses. We'll just use the amazing power of additive multiplicative inverses. So in this case, generally, if I have negatives in front of x's, I just try to think, what can I add or subtract that's going to leave my actual x term positive? That generally makes everything easier. So in this case, I would add 2x, or I could add 3x to both sides. I'm going to go ahead and choose to add 3x, because what's the opposite of negative 3x? Positive 3x. So we're going to add 3x here, and notice how I put it right below the x's. But what we do to one side, we got to do to the other side. So we're going to go ahead and add 3x here. And remember, let's just go ahead and get our like terms together. So let's combine like terms here. Negative 2x plus 3x. Now, how do we deal with this? Well, I just kind of wrote a little example up here. If you have 2x plus 3x, you get 5x. Really what you're doing is you're adding the coefficients. These numbers right in front of the variables are called coefficients. So if you have x with an x, we just add the 2 and the 3. It's kind of like if you have 2 apples and you add 3 more apples, well, how many apples do we have? We have 5 apples. So that's what we're doing here. We're combining like terms. So negative 2x plus 3x, we add the coefficients. So we have a negative 2 plus 3. that gives us a positive x. And then the plus 6, we didn't do anything to it. There's no number below it, so we're going to bring that down. Let's keep our equal sign generally in the same little column. Now, negative 3x plus 3x, those cancel their inverses. So that just gives us 0, but we're not going to write it. We didn't mess with the 21, so let's bring it down. Now we're left with something that feels familiar. We just need one more step to get that x by itself. So let's do the opposite, do the inverse. The inverse of adding 6 is subtracting 6. And what we do to one side, we have to do to the other. We didn't mess with the x, so we bring it down. 6 minus 6 is 0, so x plus 0 is just x. We can just leave that the way it is. And then 21 minus 6 is 15. So once again, we want to go ahead and check it. When we substitute 15 into the original equation, does it make it a true statement? Does this side really equal the exact same thing as the other? So if we want to check it, we want to check what this side ends up being equal to after we plug in a 15, and we want to check what this side is equal to after we plug in 15. So if you take a look up here, I wrote this is the left side of our equation, and I went ahead and substituted in a 15. We get negative 24 for that side. And then this was the right side of our equation, negative 3x minus 7. I substituted 15 in for x and check it. Boom. Got negative 24. So we know we're right. These two numbers being the exact same tell us our equation is true. Therefore, we know x has to be 15. All right, let's go. Look at this beautiful, amazing equation. So at first you might be a little intimidated. It's got the distribution going on with the parentheses. There's fractions. So let's just make this a little easier on ourselves though. Okay. Remember, with number 2, if we multiply by whatever those denominators are, we can simplify it and make the fractions go away. But in this case, you need to notice this denominator is a 5 and this one's a 4. They're different. So now if we multiply everything by 5, it'll simplify this one, but not that one. And likewise, if we only multiply by 4, we'll simplify this one, but not that one. So how do we simplify both? Well, we multiply by 5 and by 4, because then it will simplify both of the fractions. But remember, what you do to one side, you have to do to the other side. We cannot just multiply this guy by 5, and we can't just multiply this guy by 4. We have to multiply the entire side of the equation. So we're going to multiply the left side by 5, but also by 4. We're going to multiply by both 5 and 4. Remember, we need to get rid of this fraction, but we also need to get rid of this fraction. So 5 and 4. But what we do to one side, remember, we have to do to the other side. So if you wanted to here, you could go ahead and multiply these. 4 times 5 is 20. So this would be 20 times all this. I just went ahead and moved this 20 to the other side of the parentheses. We can do that because of the commutative property, just because we're used to distributing that way, you know. So this distributive property feels a little more tricky. Look, we have a lot of stuff going on right here, and then we got a fraction, and same thing here. So just be careful, okay? What you need to be able to identify is how many terms are in this set of parentheses right here. We have one whole term here, okay? This 2 times all this good stuff, that makes it one thing. It makes it one term. So when we distribute the 20, we're actually just distributing right here. We don't distribute inside these parentheses. So we distribute the 20 to this first set of numbers and to this 2/5. Because there's multiplication right here, that makes this whole thing one term as it relates to this 20 on the outside. So 20 times 2 times all this. The 20 is just going to multiply by the number on the outside. So 20 times 2, that gives us 40. And these parentheses are still here. We still have negative 2x minus 4. And now we do 20 times 2/5. So 20 times 2/5 is the same as 20 over 1. Let's do a little fraction simplification tips and tricks here. If you have to multiply fractions, you're supposed to multiply across the top and across the bottom, and then you get the numbers here. But simplify before you multiply. Simplify it before you multiply, okay? So before you end up multiplying across, go ahead and see, can you divide the 20 with anything in the bottom, or the 2 with anything in the bottom? Because if you can, you're just going to make your life better. Now check it. We can do 20 divided by 5. we can divide the top and the bottom by 5 here. 20 divided by 5 gives us 4, and 5 divided by 5 gives us 1. So this is just a nice little trick we can keep in our back pocket when we're simplifying fractions. Now this all becomes a lot cleaner. We just multiply across here. 4 times 2 gives us 8, and then 1 times 1 gives us 1. So 20 times 2/5 is equal to 8. So we found that when we multiply 20 times 2/5, what's going to be left here will be 8. So plus 8. Now just like this left side, the right side works the same way. We distribute the 20 to everything inside. But just like the left side, this 20 only multiplies by all of this stuff together once. It doesn't multiply inside of the parentheses. Then we distribute the 20 all the way over to 6x. 20 times -1/4. We can write it 20 over 1. That just helps us when we're reducing fractions. Because remember, when we multiply, we want to simplify before we multiply. Look at, hey, we can divide the 20 and the 4 by a number is 4. So we divide 20 by 4 and get 5. We divide 4 by 4 and get 1. So that just makes our multiplication way easier. Simplify before you multiply. So now we have a positive times a negative. That's going to give us a negative. And then we multiply across. 5 times 1 is 5. And then 1 times 1 is 1. So 20 times -1/4 gives us -5, but all of this is still there. And now we do 20 times 6x. We have to distribute it to everything. Now 20 times 6x, you just multiply the numbers together and then throw the x on the end. So 20 times 6 is 120, and then you still have the x. Now you'll notice all of our numbers just got a lot bigger, but we also don't have fractions. So that's kind of nice, right? So now we still have parentheses that we still need to deal with because we still have an x on the inside of them. So now we need to distribute the 40 to both terms on the inside. And just keep an eye over here. We're going to go ahead and distribute the -5 to both terms on this side. 40 times -2x, that's a positive times a negative. So it's negative. 40 times 2x is 80x. 40 times -4, positive times a negative, right? That gives us a -160. And then we still have that plus 8. We didn't do anything to it. We didn't distribute to it. We just got to bring that down. Then we distribute the -5. Negative times a negative gives us a positive here. 5 times 8x gives us 40x. Then -5 times positive 10 gives us a negative, and 5 times 10 is 50. So -50. And we did not do anything to this 120x. So see that -5 didn't distribute over there. We're just going to bring that down. Now, when I'm here, I like to combine like terms. We have a bunch of stuff going on either side of the equation. And really, if we could just make it look something like this, it'd be kind of nice, right? So let's go ahead and do that. So we just need to combine like terms. We have -80x. There's no other x terms on this left side. So we can just add these numbers though, right? We've got a -160 with a positive 8. So one thing I like to tell my students, so I'll tell you too, is if you have like terms, go ahead and just draw a shape around it. Make sure it's the same shape, and that'll help you out, right? Generally, you don't have a bunch of colored pens laying around. If you do, that's cool. You could use the same color. But if you just draw 2 rectangles, that's going to bring your eyes to those terms and be like, I can combine those. What I also mention is go ahead and put the sign that's in front of that term in your shape, because that's really going to help you not mess up on the signs when you're combining them. So on the left side, we'll be able to add these numbers, but check it. On the right side, we've got 2 terms with x in it, so we can combine those. Let's just choose a different shape. So how about a triangle? Why not? It doesn't have to be the prettiest triangle in the world. And remember, try to get that sign that's right beside the number inside the shape you drew. It's going to help you with making sure you're keeping track of all those negatives. So let's combine like terms. We can't combine anything with the -80x, so we just bring that down. -160 plus x is -152. And then here we have a positive 40x plus 120x. That gives us 160x. And then we didn't do anything with that -50, so we bring it down. So one other tip I want to give you about combining like terms here is I hear students say, oh, a positive and positive is a positive, and a negative times a negative is a positive. But that's not always true, okay? That's only true for multiplying. But you need to understand that when we're combining like terms, when we're adding and subtracting numbers with signs, the rules are different than if you're multiplying numbers with signs. So in this case, because we're adding them, if the signs are different, you're like subtracting. because you're going to have positives and negatives outweighing each other and canceling some stuff out. In this case, we have a really big negative number and a smaller positive. So because the negative is bigger, it's going to leave this term as negative. Then you just subtract the two. 160 minus 8 is 152. So now we have an equation that looks really similar to this. So like I mentioned over there, you just want your x's on one side. And in this case, I actually want to cancel this term because this is a negative 80x. This one's positive 160. If I can just choose something to add or subtract that leaves my last x term as positive, that's always going to make my life easier because it reduces the amount of negative, little mistakes that I can make. So in this case, I want to go ahead and add 80x here. But what we do to one side, we got to do to the other side, right? Why? Because they're equal. We knew that, right? Remember, I put the 80x with that. Keep the x's with the x's, keep the constants with the constants. And one last little shortcut you can do here if you feel comfortable with it. You're about to have x's over here, so you don't really want this 50 there. So you can actually do more than one addition or more than one subtraction in one step if you want. In this step, we can add 80x to this side and that side, but we can also add 50. Why would we add 50? Well, it's the opposite of negative 50. But what we do to one side, gotta do to the other. Now we just combine like terms. Negative 80x plus 80x is 0. That cancels. Negative 152 plus 50. It's the same thing here. The signs are opposite, so we subtract them. 152 minus 50 is 102. And then check it. There's more negatives than positives, so this is going to be a negative number. Equals, combine like terms here. They're both positive, so we're just adding. So we get 240x here, and then negative 50 plus 50 is 0. So those cancel, and this is where we're left. And yes, the numbers are a little bigger, but we're about to divide, and stuff's going to go away, and it's going to be amazing. So we need to get x by itself, but it's being multiplied by 240. What's the opposite of multiplying by 240? Dividing by 240. And what we do to one side, got to do to the other. So now I know this is going to give me a 1. That's why I divide by 240. 240 divided by 240 is 1. So just standard practice in math, if we're solving an equation, we're going to leave our final solution with our variable we're solving for on the left side. So I'm going to go ahead and flip this. So on the right side, we're left with negative 102 over 240. But we can reduce that. You may not know what the best number to choose is to divide them both by, but one thing you can always do is just see, are they both even? Well, yeah, if they're both even, we can divide by 2. So we divide the top by 2, that gives us 51. Divide the bottom by 2, we get 120. Now, the top and the bottom number, they're not both even, so you know that doesn't work. Upon just looking at it, honestly, I wouldn't know what else I could do. So this is the next thing you check. You see if you can divide by 3. Can you divide the top and the bottom by 3? Well, you may not know if 51 is divisible by 3, but here's a fun little trick. If when you add the digits in a number and you get something that's divisible by 3. So for example, 5 plus 1, what do you get? You get 6. If 6 is divisible by 3, then this number is actually divisible by 3. It literally always works. So because in this case, 6 is divisible by 3, we can actually divide 51 by 3. And check it here, 120. You may not know. Is 120 divisible by 3? Well, add up all the digits. 1 plus 2 plus 0 is 3. You can divide 3 by 3. So both 51 and 120 are divisible by 3. If you don't know these, you can just use a calculator. 51 divided by 3 is 17. And then 120 divided by 3 is 40. So neither one of these are even. 1 plus 7 is 8. You can't divide 8 by 3. 4 doesn't work. 5 doesn't work. Actually, if you notice, 17 is prime. So this is as far as we can go when it comes to reducing. But remember, don't forget that you had negative 102 over 240. So this is negative 17 over 40. So don't be afraid here. Even though we have a fraction as an answer, I know sometimes you're like, oh, did I do that right? I must have messed up. But we can check it, right? Let's take negative 17 over 40, substitute it into our original equation here before we even multiplied and see what happens. So to check it, we need to take the left side of our equation, that's all this right here, and then plug in our x. Our x was negative 17 over 40. So see where the x was, I plugged in our answer, we get negative 5.9. Now if we take the right side of the equation, see, I just rewrote everything on the right side, but instead of our x's, substitute in what we said our solution is, we also get negative 5.9. So because we know if you substitute in negative 17 over 40, you actually get an equal statement. Both sides really are the same. You know you're right. You don't have to worry. So that is our answer. So if you learned anything from this video, don't forget to give it a thumbs up and don't forget to subscribe. Mr. Otwell out. Peace.